Good morning. Last two sessions. Let's everybody sit down, please. Can I have your attention? Okay, the next program concerns Texas A&M's program that we had a hand in sponsoring. And immediately to my left is Professor Anish Jantrania, the registered PE in 4 states, including Texas. He's an associate professor and the extension specialist for Texas A&M AgriLife Extension and Research, Texas A&M Biological and Agricultural Engineering Department. I'll turn the program over to him. It's his baby now. Thank you.
All right, good morning. Howdy. Everybody awake? Okay. Aloha. Oh, all right. Good. Well, once again, thank you very much for this invitation to give a little talk in front of you, and appreciate the opportunity to present our program, give you some update. But before we start, I want to introduce 2 young fellows here. Roy Ward, he's going to be another speaker with me, and Michaela Vera. These are our bright students. They went through this program that we're going to talk about. And as our first speaker this morning said, John Blunt, that this is the new young generation. And look at them, well dressed up. And they also dressed up for me. So, and they're going to demand a lot of changes in our industry. And what we're doing is we got a little grant that I'm going to tell you about more. And they went through this program. It's an exciting time for them, for us to talk about. So let's start the presentation. First of all, what is this thing, what we call REEU? It stands for Research Extension Experience for Undergraduate, REEU program, okay? And we're going to start with a quiz for you. Let's see. Who attended my presentation 2 years ago at this show on March 16? Who was here? You were? Oh, quite a few. Okay, good. Let's see, you remember. Did you remember me reporting back then that we received a NEFA grant from USDA for this particular project? Who remember that? See, that's why when we get CEUs, you got to remember certain things, okay? So, so anyway, I did report to you because we were very excited about this grant, but we had nothing to report back then. So then I said, oh, wow, we're doing this program. And by the way, NEFA stands for National Institute for Food and Agriculture, which is a part of USDA. Most of you are probably familiar with United States Department of Agriculture. So this is a federally funded project in Texas at Texas A&M that we got the money for several years back. One of the things we do at A&M, all the faculties are required to write grant proposals. So we wrote a grant proposal. It has this long title, Integrated High-Impact Extension Research Education Program for Undergraduate Students. It's mainly for undergraduate because we want to have those young kids get excited about what we do so they can come back and work in our industry. And the program was in water quality, so it was a bit general concept, water quality, but focusing on on-site wastewater treatment system. So that was our proposal. We got selected. And we couldn't do much in 2016, but this was our last year, was our first year for the program. And there's some brochures that we had put together. But the most important thing was this, the training center, our own training center, which we had gotten ready with the help of TOWA members. It was built with the help of TOWA members, and it got recreated again. So we used that center to do this program. The interesting part of this program was this, in the middle, as you can see. These are fellows. So this is a fellowship program. The students got $2,500 stipend to work with us, or what I call to play with us in on-site industry. They got free housing on campus at A&M, meal allowance, some travel allowance, and opportunity to go on the international trip, Belgium trip. And in a minute, we'll talk about all these things. All right. This year, the application is still open, and I want to make sure you remember this. We extended the deadline. The deadline was March 16, but now it's in April 2nd. And if you want more information, you still have probably a little time. Ryan Gerlich, we have one-page flyer that gives you details. So if any of you have any children, grandchildren, going to any colleges in state of Texas as an undergraduate, they can apply. And there's an application process online and whatnot, and the application will stay open till April 2nd for this year program, okay? So here's a little funding agency information. It came from USDA, and it's a federally funded project. So first thing happened was we had applied for $300,000 grant, but it always happens, it's a federal money. They said, we don't have $300,000, can you do the same work for $275,760? I was like, okay. So we did cuts a little bit, but we did manage to get that much money. We got some, a little less money, not too much. They did take away some money, but it was okay for 30 students. Here are co-PIs. These are my colleagues. Dr. Al Ferris, he's from Prairie View. We are joint partnering this project with Prairie View University. And then we have Clyde Munster, Professor Munster, he's our Biological Agriculture Engineering Department. That's myself, Dr. Miller, Patricia Smith, Dr. Smith, and Dr. Gentry from Soil Science Department, and our own Ryan Gerlich. Ryan was the man. He made it all happen. Ryan, stand up. There's Ryan. This gentleman right here single-handedly got the center ready. He did a lot of work, and we got to give him a lot of credit. So Ryan did a lot of work, so he's one of the co-PIs. So 6 of us and 30 students. So go figure. It was a very good combination. We enjoyed the thing. So last year, application time about in late March. So we had some glitches right from the beginning, right? So March 30th was the deadline. This is 3 days before the deadline. What we got an email that there were 6 students has applied so far. This is 3 days before the deadline, all right? And we had to have at least 10 students to do the program. And we were like, what if people don't show up? And I was really worried. And I'm the kind of guy that if I want to do something, I'll plan a month ahead. And this is 3 days before the deadline. We had only 6 students. We needed 10. The question was, what we'll do if we don't get 10 applications? That was a big question for us because it probably would make us look bad in front of funding agency. And in 3 days, we were surprised that these young kids, they do everything at the last minute, right? So by March 30th, as was the closing time appeared, we had 45 applications. So imagine that. I was like, oh, okay, we learned something. They do things at the last minute. They turn in their homework last minute. They turn in their test last minute. So that was a pleasant surprise. So one guy was so excited, guy or girl, somebody, he applied twice. So we actually had 44 applications. So we figured we were going to take only 10, but we said, wow, there's so much interest. So we asked our funding agencies, I said, okay, we have to train 30 students for this $275,000 in 3 years. I said, can we do it in 2 years, and can we make 15 students this time, and we'll worry about next year? They said, sure, go for it. So we're going to have 15 and 15. We did 15 first year, 15 this year. So that helps us condense from 3 years to 2 years, and we'll wrap it up in 2 years. So we did 15 last year, 15 this year, okay? So we had applications. The nice thing about what we were pleasantly surprised that we had applications from a lot of different places. We had 28 applications from A&M, our own campus. We had 5 applications from Prairie View, 11 from another universities. So we had people from Florida, Kansas, Mississippi, Tennessee, Kingsville, and the Ohio State. They all applied. Then they were from agribusiness all the way to wildlife and fisherman science. So it's open for everybody. Whosoever is interested in water quality can apply for this program. So we were quite pleased with the pool of applicants. It took a time to select 15 students, and here's our first batch, all of 15 of them. There are just 2 here. I think a couple of them did come for this conference. So these are the first 15 fellow students. They were selected, and the most interesting thing, we got 7 from our own university, A&M, 5 from Prairie View, 3 came from out of state. But you notice, 10 female and 5 male. How about that? Yeah. So we do have interest. It's kind of like a good representation. So we were very happy with the student who applied. And we had a long list of things for them to do. We had to keep them busy, but most importantly, they were going to learn about how to do research if they decide to go to in a graduate school or something like that. So we had a whole bunch of research topic laid out for them. I'm not going to go into detail here. They also were going to get experience on doing extension work. both Ryan and I work in extension, agri-life extension. So we want to make sure they feel comfortable about doing a little bit of extension type activity. And so they had a 5 busy week. So this was their 5-week program, right from introduction all the way to doing a bunch of research project and all that good stuff. So we kept them busy. And the way we trained them was 2 things. This is some of the pictures of their instruction method. So they had in-class training, where they hear from all the faculty members about different things about water quality, soil, and on-site system. They also did a lot of field work. So this is our center. See how pretty it looks? It was cleaned up nicely, and then they were ready to go work there pretty much every day in that week. When they were there, they learned about how to collect samples from septic tank, then how to analyze them with using some of those DO meter and pH meter right there on site. They also learned about how to look under the soil. What happens when you put that aerobic treatment effluent under, using drip system under soil. So these are some of the field pictures that we took while they were working there. And they also they did a field trip to go look at the soil, how you analyze soil. So this is Dr. Gentry's. He's got a lot of field sites. So he took all of them over there. And you can see he's teaching them how to create texturing and whatnot. They got some experience doing sample analysis and labs. Here's some more pictures. Right in that group over there, they actually visited the private lab where they could see how the samples are being analyzed. And then, we had visitors. We had a bunch of out of our own campus speakers. Actually, Randy Salette from our executive director, he also came, gave a little talk. This is the talk from our other extension program on the Well Owners Networks. We actually had a visiting professor from India, so I made him give a little talk. He presented what he does in India. So, but towards the end of the program, this was the highlight. We took them out to the nearest company. This is, I think, this is the Sissy Bob's company, South Texas Aerobic Team, where they looked at how the tanks are made, what some of the technologies the Sissy is selling, and the most important thing, look at this fantastic T-shirt, right? On-site sewage company. And I was a little bit worried because Sissy kept telling me that, like, why these kids want to come in the on-site industry? And it's so hard. They should just get a job. And I said, no, we want them to be entrepreneur, and they can be a business. And so you just teach them how they can do a business thing. So it was a good experience. So we appreciate their help. We're going to talk to you a little bit about what kind of research they did. So back our center, we have real-time aerobic units. So we picked 2 aerobic systems. This was our septic tank, raw sewage coming into tank 2, which is a clear stream aerobic. And I think tank 3 was the biomicrobics. So we picked 2 aerobic systems. Then they all mixed up the effluent. They went to the drip system. The idea for the students was to study how different technology work, what kind of effluent quality we get, when these technologies are running properly, that means the blowers are on, and when you turn off the blower. What happens when somebody turns off the blower? So that was kind of exciting experience for them. We also kind of got them into the drip field where they look at the effluent quality at different depth. And then they collected a lot of data. So when you go out work in the field, you have a lot of data points. And so they kind of created the tables, charts, and make some sense out of it. And what did they learn? Oh, we had all kind of assignment for them. What did they learn? We're going to have Roy, who is getting ready to speak, to talk about what they learned from this experience. Roy, you're next.
Good morning. Or as we like to say from College Station, howdy. All right, so I'm going to lead into my presentation a little bit. Like Anish was saying earlier, there was 14 other students and we all got together and we applied and we got accepted in this great program. So we all together were split up and we did different projects. And my project was concerning with the biomicrobics membrane filter when it was operating and functioning correctly and when the blower was shut off. And so we took data and we did samples prior to when the unit was shut off, and then after that, the week after we shut it off, and we took samples from the tank 1, which is the raw sewage, and tank 3, where this ATU is located. Here's a diagram showing just kind of the orientation on site of where the tanks were. So tank 1, that's your raw sewage, that's your black water, that's like your primary settling tank where all your heavier sludge settles to the bottom, and then the lighter particles are then transported to your biomicrobics tank 3. And here's just a little picture of kind of what it looks like inside the tank, because we all know that when you install a septic system, most of it's kept underground. And so there's Dr. Gentrania. He's messing around there and showing you that's what the water looks like after it's gone through the membrane filter. And although it appears to look like you can drink it, and it has very little odor, I wouldn't put it in your water cup and drink that. So what we actually did is we measured the quality of the water. And so we took samples from each tank, from tank 1 and tank 3. And actually in the third tank, we didn't take them from the tank itself, but from the water that was shooting out of that hose right there. That's the water that we took samples of. And so these samples, we took various quantities, and we did on-site measurements of like your dissolved oxygen, the pH of the water. We tested for turbidity, nitrates. We did a wide variety of samples, and then other quantities of the water that we shipped off to Aquatech, which is a private lab located in the Bryan College Station area. And then AgriLife is another lab. And then the HEAP lab, that's a building on campus where we actually, as students, we got to go and perform in-lab testing. And we did the same test. We test for fecal coliforms. That's something that we were not able to do on site because it takes longer than just instantaneous results. So then after we gathered all the data from these various labs, we did data analysis and compared the results on those. And here's just an example of one of the many data analyses we did. So on the 7th, on June 7th, there's not any results for that day because we didn't measure pH. And if you look at the 8th and the 12th, that is the difference in when, on the 8th is when the system was fully functioning, operational, just like it should. And on the 12th is when we had a malfunction, or where we simulated a malfunction and we shut the system off manually. And as you can see, the pH measurement ranges from 6.8 to 7.83. And there's variations between AgriLife readings and then the readings that we did on site because, you know, there's going to be differences in the instrumentation used. Some are going to be less accurate than others, and so on. So this measures, this is our data for the dissolved oxygen. And if you look in tank 1 on the 8th, that's kind of what you think it should be, because you're not introducing any oxygen into the system. But if you look at tank 3 on that same day, you have oxygen levels of 4.83, and that's expected. You expect those oxygen levels to go up because it's an aerobic treatment unit. So you're introducing oxygen into that water and allowing the microbes to take in that oxygen and decompose that waste and further purify and disinfect that water. And as you can see for the 12th, that's when, again, our treatment system was shut off, and you have similar readings in your oxygen levels. Now, one thing that we were unsure about is why was our oxygen levels in tank 1 so much higher than in tank 2 when that's where you introduce your oxygen. Now, we saw that as maybe like an error, and maybe our measurement, whoever on site did like the measurement reading for the dissolved oxygen might have, you know, misinterpreted the data or wrote the wrong measurement down. But that's one thing when you're doing research. You gotta make sure that whoever's taking that data is doing it with precision and accuracy, so that you can guarantee that these results are applicable to what you're looking at. And this is just basically the data analysis for the biological oxygen demand, your total suspended solids, and your total dissolved solids in that water. So this is a log scale of the percent reduced from the difference in the measurements of tank 1 and then where the biomicrobics membrane filter is. And as you can see, on the first day, we didn't measure total suspended solids, but on the 8th and the 12th, the biological oxygen demand increased, and then the total suspended solids were reduced almost to 100%. So above 95%, which that's what the treatment is supposed to do. You're not going to get all of that effluent treated to 100% efficiency. That's part of what Mother Nature is supposed to do when you introduce it into your drip field later on. And here's bacteria reduction, which is one of the main concerns when you're dealing with fecal matter. Here is all those total coliforms and fecal E. coli. So on the 6th, or on the 7th, June 7th, we only tested for the fecal coliforms there because that data was not introduced and taken and analyzed at the lab. And this is a table showing your total kildol nitrogen and your nitrates. So looking at tank 3 for both of those days, you have very, very little concentrations in your total kildol nitrogen. And that's a good thing because your bacteria that dissolves and transforms that total kildol nitrogen, when it takes the oxygen and it feeds on that total kildol nitrogen and it produces nitrates as waste. So when your system is running up to par, and we came to find out even when you weren't introducing oxygen into the system, when it was shut off, the bacteria still broke down that total killed on nitrogen and turned it into nitrates, which is a good thing because it's not a total loss. You don't have to freak out completely when your system is shut off because it's still treating that wastewater to an extent, but not to its highest efficiency. So in conclusion, as you can see with that clear water that was being pumped out of the biomicrobics membrane filter, it looks safe to drink, it smells safe to drink, but after you send all the data to the lab and run all the tests on it, you come to find out that it is not safe to drink. So by doing that, again, we tested for chloride, pH, the dissolved oxygen, and that let us know, going on behind the scenes, how that water was and the qualities of that water. And we can compare that with data going forward that was approved by the USDA on drinking standards and to let us know whether that water would be impaired if we release it into a waterway. And one of the main conclusions we did draw from this is that the biomicrobics membrane filter is an effective secondary ATU that we can use to treat wastewater, but it is not one of the only options, as we did have a chloride or clear stream solution on the Relish campus as well. So that concludes my presentation, and now it's back to Dr. Jantrania.
All right. Good job. Thank you, Yegbin. Thank you. So it looks like they're learning something, right? Yeah, I was impressed. I said, let's see if you understand the TKN and nitrate. Oh, boy, that's impressive. Thank you. Good job, Roy. So as Roy said, we took this and made it up to here, right? But he won't drink it. If he's not going to drink it, I'm not going to drink it. That's the rule on campus, right? We try to the student test at first. So well, obviously, it's not drinking water. It looks like rainwater. It has goodly amount of nitrate in it. There's not many fecal coliform in it because the membrane is very effective removing fecal. The students also learned the benefit of having membrane as a physical barrier to keep the solids. All the suspended solids always get trapped in this membrane most of the time. Students also learned that when you turn up the blower, the effluent clarity went down a little bit and it started smelling. So there is an effect. Membrane is not the end of, it's not going to protect everything all the time. So I think we learned a lot, and then we're going to build on this project. So this year, when the student comes, Ryan is working hard, and Roy is actually helping Ryan to introduce some of the new technology at our center. We're going to be adding RO unit, UV disinfection, ozone disinfection, another chlorine disinfection, activated carbon. These technologies we are buying from the water industry. So the goal is, can we take this water that the on-site industry can produce, this is the high quality effluent, and then we go to the water side, and I said, hey, the drinking water people, what do you have now? Can we make that effluent to a higher standard now? So we're going to introduce some of these technologies at our center, and then we're also meeting with TCEQ. Technologies are there. We also need to work on the regulation part. And I think our keynote speaker today did talk a little bit about what needs to happen in terms of rules and regulations. So we have a young lady right here, Michaela Vera. She is working hard to work with TCEQ about that. So Michaela.
Howdy, everyone. I'm Michaela Vara. I'm a junior at Texas A&M studying biological and agricultural engineering, and my focus is on environmental engineering. So last summer, I participated in the Research Extension Experience for undergraduates. This was my first introduction to on-site sewage facilities, and it taught me the principles and basics of water quality and hydrology. So through that, I gained an understanding of the wastewater treatment field, and it taught me the basics that I needed to know to understand that. So, after participating in the experience, I was drawn to the field of wastewater treatment, and I wanted to know how I could expand on that research. So, in order to expand, I decided to take a directed studies class, and it's research experience for undergraduates, and I'm doing a hypothetical case study at Texas A&M's Rellis campus about direct potable reuse in combination with an on-site sewage facility of less than 5,000 gallons per day. So we're using the same on-site sewage facilities, adding the new wastewater treatment technologies, and using that to develop a plan for sampling and analysis of these DPR systems. So what does this entail? In order to develop a plan for sampling and water quality analysis, regulations that are applicable to direct potable reuse systems must be reviewed and researched and then applied to the scale of the Rellis campus. In this research, as Dr. Jantrania mentioned, communication with the Texas Commission on Environmental Quality is essential in order to determine the testing parameters, obtain information about permitting, and approval of the system. A holistic review of these regulations that are in place, water quality standards, and application processes will help develop such a plan. So, as previously mentioned, input from the TCEQ is critical to the success of this project. The main objectives of the communication are to determine the requirements for an application document of a direct potable reuse system, and to determine the testing frequency and standards, as well as obtain a permit for use and experimental testing. In February, Dr. Jantrania, Dr. Cheesemash, and I traveled to TCEQ in Austin to visit with people from the wastewater and drinking water areas of the TCEQ. Dr. Cheesemash is a professor from Texas A&M School of Public Health who is helping us look at the water quality from a health standard. In our meeting, we presented a document explaining the background and objectives of this research, and followed by questions pertaining to the regulations in place for direct potable reuse systems. Prior to the meeting, I reviewed the Texas Administrative Code, Chapter 210, which covers the use of reclaimed water, and Chapter 285, covering on-site sewage facilities. After reviewing these documents, I developed a list of questions as to how these regulations would apply to direct potable reuse systems and what new regulations would be required. For instance, some of the questions I asked were, does the TCEQ have defined biological and chemical analysis requirements for direct potable reuse? And prior to sampling, would an experimental permit need to be obtained? If so, what would the documents needed be for such a permit? The meeting with the TCEQ went well, and it was informative. All of the questions we presented were answered, and we discussed this hypothetical case study. One of the questions I had was, how do DPR systems get approved if there's no regulations outlining their use? We discovered that since there is not a set standard, they're approved on a case-by-case basis. and so they're approved as exceptions to the rules. This is done because regional contaminants can lead to different testing parameters. Some requirements are specific to system size. What's done for a large-scale wastewater treatment plant versus our 5,000 gallons per day might be different at Rellis campus, and because the blending amounts may vary. So we're not going to use all of the effluent from direct potable reuse. We're going to blend it with normal drinking water. So if we were to obtain an exception letter for an experimental permit, we would test the DPR effluent. And in this testing phase, the water could not be put into distribution, and the warning system and shutoff procedures would need to be evaluated if the water quality were to be poor, and we would need to redirect that. We also asked about the approval of 3 direct potable reuse systems in Texas. They're Wichita Falls, Big Springs, and Brownwood. So after the meeting, we obtained copies of the approval letters for those systems, and they also outlined their testing, communication, and various other procedures. We also got copies of Chapter 217 of the Texas Administrative Code to further review the regulations in place regarding the quality of the drinking water. So currently, after meeting with the TCEQ, I began to compile a report outlining the findings from the regulatory reviews and the meeting. One of our discoveries was that the testing requirements are dependent upon the size of the system and on the technology of that system. And as Dr. Jantrania mentioned, at the Rellis campus, we're installing UV disinfection, reverse osmosis, ozone disinfection, chlorine disinfection, activated carbon filter, captive deionization, and high-efficiency distillation. So from that, the standards for the DPR effluent are determined by the Environmental Protection Agency in Subchapter F of the Safe Water Drinking Act. So a compilation of these requirements are going to be included in my final report to determine what the procedures and testing standards will be for a direct potable reuse system. So currently, I'm in the process of applying the regulations and parameters that have been determined to the scale of the Texas A&M Rellis campus. This includes outlining the potential testing schedule and that would be required for the application of an experimental permit. Shutoff procedures, a critical point chart for the chemical and biological contaminants, and methods to return poor quality water back to within regulations. Also, I'll be comparing the cost effectiveness of this direct potable reuse effluent with water purchased from the city of College Station. Historically, direct potable reuse systems are not the most cost effective, and one of my goals for this research is to find ways to minimize the cost while still maximizing its effectiveness. The ultimate goal of my research is to compile a document that contains all of my findings from this case study in order to assess the feasibility of using a direct potable reuse system in combination with an on-site sewage facility with a capacity of less than 5,000 gallons per day. So that concludes my presentation, and I'll give it back to Dr. Jantrania.
Hey, good. Michaela, thank you very much. So what do you guys think? They're not just going to be engineers, but there's engineers who can also talk with the regulators, right? And they're also going to pay attention to the cost. As Michaela says, cost is very important. So we're teaching them a little bit about costs, a little bit about regulations, a little bit about technology, and all about science and all those good stuff. So it's been a very good experience, and I'm very, very happy just listening to them. This is the first time I heard them in public. So this is like, okay, they can talk in public, right? So that was part of the extension training. So that's good. We will open up for questions very soon. I'm sure you're going to have some questions. But what we're doing in the bottom line is this. We have our center that was really focused on OSSF for all this time. It started in 1990s and did a lot of work about on-site sewage treatment. We're going to take that next step now, which is to build the capacity, working with the public-private sectors to add research and demonstration so that we can take this water, which is not drinkable. Nobody should drink it. Nobody will drink it, but we'll try to make it drinkable. And the reason we're doing it is not because we have nothing else to do. But I personally believe when I came to Texas in 2014, right? And I think you heard me say in 2015, I moved here in August, and I was like, wow, this place is dry. Remember 2014, towards the tail end of the drought, right? And I was scared. I mean, I'm originally from India, so I've seen dry conditions, but Texas was dry back then. I went to Wichita Falls, and I was very happy to see this big city trying to do direct bottle reuse, and I was excited. I said, this is so cool from a technology standpoint of view. But then it started raining in 2015. And I told my boss, I said, my work is done here. He said, I said, yeah, I brought rain from Virginia. What can I say, right? He said, what are you going to do now? I said, well, going into flood control. What else, right? But it is very important for us to know. I'm sure everybody knows that it's not whether we're going to have next drought or not. It is when will it come. And our goal together, at least at A&M, is to build a strong research program so we're ready for that next tough time. So we don't have to worry about whether we're going to have drinking water or not, or do we need to shower once every week? I mean, that's never a good idea. I love water. I use a lot of water at home, and I want to continue to do it even I'm in Texas, okay? So we did a lot of work. There are a lot of pictures. Here's some happy faces. The kids had a lot of fun. We were very happy that nobody had the yuck factor. That was the most important thing. I mean, I thought, wow, these kids might freak out. First time we showed them the septic tank. They didn't freak out. They really dig into it. And till the end, so you saw the first day picture, and this was the last day at the campus on the training center. They were still standing up. Nobody got hurt, and they were still laughing. So we were very happy that they enjoyed their experience, and they shared their story with us. So what's next step for these 15 students, right? So some of them, 7 out of 15 students applied for the study abroad scholarship. So they were all qualified to go abroad. They had to apply for it because we were going to pick 3. So 7 applied. The other 8 probably had something else to do. They didn't want to go to Belgium, so I guess there was something else better to do for them. So that's okay. 3 students have been selected, and guess, I think both of you are going, right? So 2 are right here. These 2 kids are going to go to Belgium this summer, spend 1 month with Dr. Munster, learn about what they do in Belgium. Because apparently Belgium do have some reuse system, and then we hear a lot about Belgium has good water and everything. So they're going to come back with more knowledge about what's happening in Belgium. So they got $5,000 scholarship to participate in Summer 2 program, Belgium study program, that is run by Dr. Munster at A&M. So give them hands. Congratulations, guys. All right. What are we doing next? A student presentation. That was part of one of the requirements that they're going to come here, present. They did it, right? So that was good. One student will continue to work at OSS Center. Guess who that is? This fellow right here. He loves it so much that he's signed up, and he helps Ryan to build this new phase of the center. We offered them, I said, hey, you guys can do an unpaid extension internship. Like unpaid, I don't know. I think we had one student may join or something like that, right? One student is helping us. But unpaid extension internship is not sexy enough, obviously. Application process for 2018 is underway. As I said, the deadline has been extended to April 2nd, so spread the word out there. We do like to have a lot of applications so we can pick the right and brightest and the right. And if any of the TOWA member knows anybody, make sure your student, your family member, friend, and if they're a TOWA member, make sure they put that in their essay. So we know that they're coming from TOWA group, okay? So they will carry some weight. We hope to get similar interest in terms of applicants this year as we got last year. And next month, I got to go make a report to the funding agency about this whole program, and they asked us to make a video. There is one student working on the video presentation. That video is not ready for view, so we're not going to show it, but next month it will be ready, and maybe we'll put it on the TOWA website or whatever. So next month I'm going back to DC to report, and looks like we might request them to extend our grant, maybe give us a little more money so we can continue doing this thing. So here's a little brochure for next year program. If you haven't picked one up, the deadline has been changed to April 2nd. We hope to get more application, and I think that's about it. So we are opening up for questions now. Thank you. Questions, comments? Yes, sir.
So one of the earlier presenters had talked about how Texas used to be leading in the research aspect of wastewater, and definitely we talked about the age gap between a lot of us
Right.
and some of this. So this is great to see. But do you see more programs or even joint programs between Texas universities and others that are leading in the future, or more funding coming?
Yeah, that's a great point. Joint program within Texas and joint program with outside Texas universities. So yes, the answer is yes and yes. We are working on a lot of collaboration with other universities, campuses, specifically from West Coast. I think Michaela did some research on the California side, because apparently California is the leader in this field. But we did hear from TCEQ that California claims they are the leader, but there is a single permit issued for direct potable reuse in California, whereas in Texas we have several cities are actually using direct potable reuse. So we are going out and looking for more funding and support on this program. So yes. Okay, what else? Come on, you gotta have some questions for these kids. Yeah, sure. Yep, Michaela. Yeah.
The three that have permits, what was some of the criteria, or do you remember offhand?
Some of,
Testing?
okay, so some of the criteria for those tanks, or for those systems. So some of the criteria were that, for example, the experimental permits for use, they had to meet 4 phases, so essentially all of the seasons over a year-long period seemed to be the general amount of time of chemical and biological analysis like parameters, and each of those are different. I would throw numbers at you, but they wouldn't make any sense because they're just, it's dependent on each system, but they would have to go through that phase of 4 different system, I guess, environments, and in those environments they would simulate when the water quality is poor, and so they would have to meet those testing requirements, and then they would simulate communication between the system and the wastewater treatment plant. If for some reason there was to be a flood and it reaches capacity, where would that water go? And so basically all of these emergency systems and emergency procedures were tested before they would be put into use. There were a lot of, it was a huge document. It's about this big, if not larger. Yeah.
Typical government?
Yeah, well, just to add a little bit on it, that's what we hear about typical government bureaucracy and whatnot. I used to be a regulator in my previous lifetime, okay? So I understand the theory and philosophy behind the need for regulations. Interestingly enough, water is such a thing that we all tend to take it at its face value, as long as it doesn't come from wastewater side. So the point is the putting wastewater back into the building is a very serious business. And I think if nothing else, all of us should appreciate the seriousness behind that. And the seriousness is, if one person gets sick or die for whatever reason, and it gets back to the direct potable reuse concept, it'll be terrible for the whole industry. At the same time, a lot of people die because of bad water every day, and nobody complains about that because we take it that, oh, it comes from nature. If something wrong, it's the nature's problem. So with all that due respect to TCEQ, and believe me, I sat through that meeting, and I get the feeling that they're serious about it. One of the biggest challenges is not the treatment technology, the biggest challenge is the monitoring sides. How would somebody know when something goes wrong? Because this is online, this is a continuous process. And ability to shut that valve off from the reclaimed water side at the point, at the right minute before it contaminates the whole water supply, that's the most important thing. So it was a very good experience. Any more questions? Yes, sir. There's one fellow back there. Oh, there's one, okay.
I'm just kind of curious what was the reason behind choosing Belgium as somebody a place to go study
Choosing, Belgium?
Yeah, why Belgium and not some
Uh,
other?
Texas A&M has an ongoing summer program with Belgium for last 28 some years. So there is an institution in Belgium that Texas A&M is partnered with, and for last 20 some years, the students are going there. So that's why we're just tagging along to that program. So it's nothing new for this one. Yes, sir.
Good job, Roy, and good job on your presentation. One of the questions I had was in Roy's presentation, he showed the E. coli reduction, and you had 3 data points. I'm assuming that at the first data point, the E. coli concentration will be too numerous to count, or TNTC. I didn't see a point on the second one, and then, of course, on the third one, you showed a substantial log reduction in E. coli using the membrane. So my question is, do we have any data points in there between, and what would you expect to see for a longer trend? Was the reduction in E. coli more linear, or did it vary with temperature? I mean, how would you have graphed it? How would it look?
All right.
This thing on?
Yeah.
So with that, I would expect it to be pretty constant going across the board, especially because there's very little variability within your biomicrobics membrane filter unless you started to get kind of a buildup in there, because it literally is a filter. So, I mean, just like with any other filter, your air filter in your house, you will experience a decrease in efficiency when you go an extended period of time and there's a buildup on the face of that. So, I don't know if this is completely true, but I think there's a way to backflush the system and essentially clean the face of that filter. Like it's very complicated interface with the. I mean, it's user friendly, but to understand it, you'd have to really go into the operating manual of the technology itself. But I would expect it to be pretty much a constant reduction in the fecal coliforms. Now, a lot of what it has to do with it is your input. So I think there was an influx in the amount of people that were using the building where all of this wastewater was coming from. So I think like on this particular day, the 7th, there might have been a lot less. There might have been a lot less of the fecal coliforms found in the water. So the membrane itself was able to treat and nearly get all of that matter out of there, whereas like they might have just come back from a break or some kind of paid leave or something like that, and they had way more fecal coliforms and were not able to reduce it to 99.99% like they did that previous week. So it happens. It really depends on the amount of, or the quality of the water that's coming in, what you're going to get coming out, if that answers your question.
Very good. More questions? Yep, there's a question way back there. Yes, sir. You have a microphone? Grab the microphone, please.
I got a daughter that I'd like to give this information to, and she is, going into the field of medicine. And so, is this like a scholarship or grant and then too, say like if she won, would she be going to Belgium as well, or to another country, or what and how long would the trip be for? And
Okay.
so would she have to take those funds and use it on that trip, or is that something y'all foot the bill too?
A lot of questions. The simple answer: this is a summer program, so it's just for 1 month of internship, and you got to apply. From medicine is fine, because medicine also needs water, so it's good to know, all the doctors should know a little bit about water. If she applies and if she gets accepted, she will have this summer, 1 month, the fellowship to come and learn about water quality. And then once that program is over, out of those 15 students will apply for the Belgium trip. And I think this year we just have money for 2 people to go to Belgium in 2019. And that Belgium trip, she will get $5,000 to cover some of the cost of Belgian trip, and that trip lasts for 1 month. Okay, so there is some, it's not, I think the actual trip costs a little more than 5,000, but first 5,000 are paid for. And if you want more information, you can always stop by after the show here. So, any more questions?
Can a student from the University of Texas at San Antonio?
Oh yeah, everybody from Texas can apply. As a matter of fact, this is a federally funded program, so we accept applications from all over the country. Any more questions? Yep. Okay, sure. Oh boy. Oh, okay. That's
Mike for Mike.
Yeah, Mike for Mike.
Hey, good morning.
Good morning.
I'm going to try to keep this simple. Okay, your various components have been tested under various standards. For instance, the biomembrane, definitely a certified unit. I don't know as much on the next set or collection of technologies. What I'm going to ask you, and you've already got a lead in for this, okay? For instance, under NSF Standard 40, there's a protocol for variation in loadings, variation in cycles, how it behaves. And Roy kind of spilled the beans a minute ago because he admitted part of the real world, which is that the performance of the treatment component will vary somewhat according to loading. Now we combine that with the fact that an OSSF system is at the jumpiest, jitteriest, least steady state end of the wastewater industry. So my question to you, and I know you've got to prove basics before you get too wild, okay? But are you guys going to put together some kind of a protocol, okay, for some degree of a controlled variation? And I know it's not easy, but a controlled variation in your input loadings and also your hydraulic load. That's my question.
Oh, yes, there are a lot of questions in there, Mike. And you heard the beeper, so I think I don't want to cut up any time on to you. But the answer is yes and no both. This particular program is just to train undergraduates. And we want to make sure, we had several obvious goals. We want to see the interest in the young generation about this. And I got to tell you what, our first speaker said there is a lot of interest in direct particle reuse. All these kids are really excited about getting there. Now, so the interest is there. The second thing will be, yes, it's not a simple matter of doing one project and say, oh, this is all works. No, it's not going to be that simple. In terms of our ability to put together any protocol, it is a tough challenge, but we're thinking about it because at least we want to teach them something. And what is the protocol? Why do you want to make sure we test not just in the normal situation, but in the abnormal situation, which will occur in any given moment? And one of the biggest challenge for OSSF, as Mike says, is this instability, making sure it is an individual home system, the flow varies, the concentration varies. You got party today, somebody gets sick tomorrow, you got a sick relative coming to your place, a lot of variations. And how do you make sure that your treatment takes all that beating? So that's the most important thing. So we will put together something as a draft, but that's not going to happen in the near future. Right now we are focusing on getting the technologies there, making sure the flow goes through it the way we think it needs to go. And the best news about all this thing is this little Relish campus, everybody should know it, it's no longer Riverside campus, the Relish campus is growing. In about 2 or 3 years, we're expecting 20,000, 30,000 people working there. There's going to be campus, Blinn College, and all those things. So we're going to have plenty of sewage to play with. And once you have a lot of sewage to play with, we can simulate a bunch of different situations. So we will work towards that. And I think with that, do we have time for one more question, or we're good? We're good with time? One more last questions? Any comment? Sure. Okay.
Have you analyzed the cost of this kind of system versus desalination?
Cost of this kind of system was to desalination. Anytime somebody asks me for cost, I say, how much did it cost? $2 million. Now, No, we haven't put together the actual cost figure. I mean, you all know how much biomicrobics cost, right? So that we're good up to that. Right now, we're buying off-the-shelf reverse osmosis, off-the-shelf UV disinfection kind of thing. That comes from the water industry. We had a seed grant for about, $20,000 that we're using to buy all these gizmos. They are expensive. We haven't put together the actual cost table yet, but that's our ultimate goal, to figure out what 1 gallon of that reused water will cost. Okay? Yes, sir.
In response to him about the irregularity, did anybody consider putting this system, this test, on a time dosing influid, where you have greater detention time for the incoming, from the holding tank, for dosing to the unit, for greater mixing? And
The short answer to all this thing is yes. The treatment plants are time dosed. They are time dosed, right? Yeah. We control. The flow is very controlled in the controlled method. So.
I had to ask, 'cause it wasn't.
No. Those were some of the internal details. So I think with that, we are ready to wrap up. Thank you very much for your attention. We'll get going here.